Hello. In this video we're going to go over section 3.2 homework solutions where we talk about Rolle's theorem and the mean value theorem. And it's a lot of problems that we're going to go over, but I think it'll go pretty fast. So number one, if I'll bring that graph into view there, it says state why Rolle's theorem doesn't apply. Well, for Rolle's theorem to apply, it has to be continuous. The function has to be continuous and differentiable. And here at x equals 1, you can see there's a sharp turn. So at x equals 1, the function isn't differentiable. So Rolle's theorem does not apply there. All right, so on number 3, the next several, we're checking out if Rolle's theorem applies, and if so, where is the horizontal tangent line. So our function on number 3, we have x squared minus 2x. Our interval is from 0 to 2, so if we plug in 0 into the original function, we get 0. If we plug in 2, we get 0. So Rolle's theorem does apply because that is a continuous, it's just a parabola. That's a continuous function, so we'll take the derivative. That'd be 2x minus 2, set it equal to 0, solve for x, and the point where you have a horizontal tangent line is at x equals 1. All right, number 7, we have x to the 2/3 minus 1, and our interval's negative 8 to 8. F of negative 8, when you plug that in, you get 3, and then positive 8, you plug that in, you also get 3. So Rolle's theorem, at least as far as f of a equals f of b, does apply. Let's take the derivative. You'd have 2/3 x to the minus 1/3. I'm going to rewrite that as 2 over 3x to the 1/3. Set that equal to 0. Well, this will never equal 0. This derivative never equals 0. So it is undefined at x equals 0. So in this case, Rolle's theorem on number 7 does not apply. All right, number 10, we have f of x is equal to x squared minus 1 over x. We really don't have to do much work on this one because the interval is negative 1 to 1. And you can see that when x equals 0, which is within this interval, that f of x is undefined. So if it's undefined at a spot in the interval, then it's not continuous, and therefore Rolle's theorem doesn't apply. And we didn't even have to take the derivative on that one, where we did on number 7. Okay, number 11, we have f of x is equal to sine x. If I plug in, the interval is 0 to 2 pi. If I plug in 0, I get 0. If I plug in 2 pi, I get 0. So Rolle's theorem applies. This is a continuous sine wave. The derivative is cosine x. We'll set that equal to 0. And if you look at your unit circle, you'll see that cosine x is equal to 0 at pi over 2 and 3 pi over 2. So that is our values of c, where we have a horizontal tangent line. Okay, let's look at number 13. So we have f of x is sine 2x. Our interval is pi over 6 to pi over 3. So a short little interval there. F of pi over 6. So if we plug pi over 6 times 2, that'd be pi over 3. The sine of pi over 3 is the square root of 3 over 2. And f of pi over 3, if we plug pi over 3 in, that'd be 2 pi over 3. If you look at the unit circle, the sine of 2 pi over 3 is also the square root of 3 over 2. So Rolle's theorem does indeed apply. Because the sine of 2x, that's just a sine wave, doesn't have a place where it's undefined. So let's take the derivative. That's going to be cosine 2x times the derivative of the block, 2x, that's 2. So I'm going to bring that 2 out front. Let's set that equal to 0. All right, so where is cosine 0? Well, it would be 0 at pi over 2. So if I plug in pi over 4, multiply that by 2, then you're taking the cosine of pi over 2, which is 0. And that is within the interval pi over 6 to pi over 3. So that is our value of C, where you have a horizontal tangent line. All right, number 15, we have f of x is equal to tangent x. Now let's rewrite that as sine x over cosine x. Now our interval is from 0 to pi. Well, is there anywhere between 0 and pi where cosine x is equal to 0? Well, there is a spot. When cosine of pi over 2 is equal to 0. So that means that this function tangent is undefined, and it has a vertical asymptote at x equals pi over 2. So Rolle's theorem does not apply, because we have a place in the interval where it's not differentiable. Okay, let's do 21. So we've got f of t is equal to negative 16t squared plus 48t plus 32. All right, that's just a parabola, so there's not a place where it's undefined, no denominator or anything like that. It says in part A to verify that f of 1 is equal to f of 2. So f of 1, if we plug that in, f of 1 would be 64. And I'll let you do this in your calculator, but if you plug in 2, you'd also get 64. So that means Rolle's theorem applies. All right, f of A is equal to f of B. It's a continuous and differentiable function. Part B says, according to Rolle's theorem, what must the velocity be at some time in the interval between 1 and 2? Okay, so this is the position function, the velocity function. You don't even have to do any work here. We know that the theorem says that the derivative is equal to 0 at some time between 1 and 2. So v of t has to be 0, according to Rolle's theorem, between 1 and 2 seconds. So there wasn't any work. You just had to apply the theorem to it. So you didn't have to take the derivative and find. It doesn't even ask you what time that occurs. So you don't have to solve for anything. Okay, that's it for our Rolle's theorem problem. Now let's move over to the mean value theorem. With number 27. Okay, so the instructions are we want to apply the mean value theorem on the indicated interval. 27, we have f of x is equal to x squared. And we're between negative 2 and 1. Okay, so that's just a parabola, so it is differentiable on this interval. So we want to get the slope. So that's going to be f of 1 minus f of negative 2 over 1 minus negative 2. F of 1 is 1. f of -2, -2 squared would be 4. 1 minus -2 would be 3, so that's going to be -3 over 3, which is -1. So we want to set the derivative equal to the slope. So f prime of x is equal to 2x. We're going to set that equal to -1. So x is -1/2, and that is our value c, where the slope of the secant line is equal to the slope of the tangent line. At -1/2, those two are equal. It's an important concept on the AP test. You get a lot of those types of questions on the AP test where you have to apply the mean value theorem and explain it. All right, number 29, we have f of x is equal to x to the 2/3. And our interval is 0 to 1. So this isn't Rolle's theorem, so f of a doesn't have to equal f of b. So you don't apply that test like you do with Rolle's theorem. But this is a continuous function, x to the 2/3. Let's get the secant slope. That's going to be f of 1 minus f of 0 over 1 minus 0. So 1 to the 2/3 is 1, 0 to the 2/3 is 0. So we have a slope of 1, secant slope of 1. F prime of x would be 2/3 x to the minus 1/3. So I'm going to rewrite that as 2 over 3x to the 1/3. And we're going to set that equal to the slope, which is 1. So multiply both sides by 3x to the 1/3. You'd have 2 is equal to 3x to the 1/3. So 2/3 is equal to x to the 1/3. Let's cube both sides. All right, and so we would have 2/3 cubed is equal to x. So that would be 8 over 27 is equal to c. All right, so interesting fraction there. But that is how you do it. All right, moving right along, maybe a little faster than I thought we would. Let's do number 31. Number 31, we have f of x is equal to the square root of x minus 2. And our interval is 2 to 6. Okay, let's rewrite this as x minus 2 to the 1/2 power. Now I've got to get the secant slope. That's going to be f of 6, so that's the square root of 4, which is 2, minus 0, f of 2, over 6 minus 2, so that would be 2 over 4, which is 1/2. So that's what we're going to set the derivative equal to. So f prime of x is 1/2 times x minus 2 to the minus 1/2 times the derivative of x minus 2, which is just 1. So I'm going to rewrite that as 1 over 2 times the square root of x minus 2 is equal to 1/2. All right, so let's let's multiply, let's move this 2 times the square root of 2. So I would have 1 is equal to 1/2 times 2 times the square root of x minus 2. The 1/2 and the 2 will cancel. So I have 1 is equal to the square root of x minus 2. Let's square both sides. So we'd have 1 squared, which is just 1, is equal to x minus 2. So x is equal to 3. And that is our value c, where the slope of the secant line, the average value, is equal to the slope of the tangent line. All right, number 33. Hope I can fit this in here. We have f of x is equal to sine x. All right, our secant slope. So the interval here is 0 to pi. So I'd have the sine of pi, which is 0, minus the sine of 0, which is 0, over pi minus 0. So our secant slope is 0. All right. So f prime of x is equal to cosine x, and we're going to set that equal to the secant slope 0. All right, and where is cosine 0? It is at pi over 2. And that is our value for c, where the slope of the secant line is equal to the slope of the tangent line. All right. Okay, shouldn't take too long to finish this up. Number 43, a word problem. So that says the height of an object t seconds after it is dropped from a height of 500 meters is s of t is negative 4.9 t squared plus 500. Find the average velocity of the object during the first 3 seconds, and then use the mean value theorem to verify that at some time during the first 3 seconds of fall, the instantaneous velocity equals the average velocity, and we want to find that time. So you're just finding the value of c there. So the average velocity between, so we have s of t is equal to negative 4.9 t squared plus 500. So and our interval is 0 to 3. So there's a couple different ways we could find the average velocity. I think I mentioned on the lecture video that you could just take the derivative and plug in 0 and then plug in 3 and take the average. We probably should do it this way. Find the secant slope. So that's going to be s of 3 minus s of 0 over 3 minus 0. So s of 3, if we plug in 3, is 455.9. If we plug in 0, that's going to be 500 over 3, and that is negative 14.7, and we are in meters per second. So we can just take, to find the average, we can just find the secant slope. So that's part A. And then part B, we want to use the mean value theorem and find that place where the slope of the tangent line is equal to the slope of the secant line. So v of t is equal to s prime of t. Take the derivative, that's negative 9.8t. And we want to set that equal to negative 14.7. So t is equal to negative 14.7 over negative 9.8. That is 1.5 seconds. So it's right in the midpoint, which makes sense because the acceleration is constant gravity there. So that is our time. Okay. So we've got a couple of true-false questions to finish this up. Number 47. So it says, the mean value theorem can be applied to f of x is equal to 1 over x on the interval negative 1 to 1. That's going to be false. So we have f of x is equal to 1 over x, and on the interval negative 1 to 1, we have 0, and it's undefined. At x equals 0, so the mean value, that means it's not differentiable at x equals 0, so Rolle's theorem does not apply. All right, let's take a look at 49. 49 says, if the graph of a polynomial function has 3 x-intercepts, then it must have at least 2 points at which its tangent line is horizontal. Well, let's just draw that out. 3 x-intercepts. So here's a coordinate plane. All right. 1, 2, 3. 1, 2, 3 x-intercepts. So there's a horizontal tangent line. There's a horizontal tangent line. And it says that there must be at least 2 points. So I would say that one is true. But we are assuming that the function is continuous and differentiable. If it is not, then you couldn't make this assumption. But if it is, and I think the book wants you to make that assumption, then the answer is true. All right, number 50 says, if f of x equals 0 for all x in the domain of f, then f is a constant function. Excuse me, f prime of x. Okay. Well, a constant function would be like this. Let me go ahead and put it in a different color. So a constant function is just a horizontal line. So the derivative of a horizontal line would be f prime of x has to be 0 of that function because its slope, right, is 0. So f prime of x is 0. So that one is true. All right, and that's it. So these 3 true and false were not as tricky as some of the ones we've had in the past. All right, I hope this video helped, and I will talk to you next video.